Remember, turn your speed down. Put it at least 1.5. I know I talk fast. Here we're going to talk about the real number system. And what's interesting to me is anytime I talk about the real number system, it begs the question, well, if there's a real number system, is there a fake number system? And the answer is yes. We call it imaginary. And we're not going to learn that until Algebra 2. So for us in this class, the real number system is all the numbers that we're going to talk about. So when I ask you to classify a number, every single one of your answers should include real numbers because that's all we're talking about in Algebra 1. Now, is it important to remember the abbreviation for these numbers? Yes, it is, because it will never change throughout the course of your math classes. So we're going to start by talking about the real number system, and it's every single number that we cover in algebra. And we abbreviate the real numbers with the letter R. And R stands for real numbers, and it's anything. It's anything that you can imagine. It's the number 4. It's the number 1/2. It's negative numbers, negative 2.67. It's pi. It's those numbers that never, ever, ever end and don't have a pattern. So they go on forever. So the real numbers is all of it. Now, we're going to break it down into smaller categories. So broad, everything we deal about in algebra, real numbers. Then it's going to go into two groups. It's either irrational or rational. That means that these guys can never be the same, ever. It's either irrational or rational. So I'm going to talk about rational numbers here. Rational numbers is any number that fits the form A over B, where B is not equal to 0. Why can B not be equal to 0? Because you can't divide by 0. So any number that you can think of that fits the form A over B, that's a rational number. Let's look at that. Does 5 fit the form of a rational number A over B? Yeah, it does. I can turn that into 5 over 1. Fits the form A over B, so 5 is a rational number. What about a number like 2500ths? Can that fit the form A over B? Yeah, you betcha. I can do 25 over 100. Now, I could reduce it, but the point is, does it fit the form A over B? It sure does. So, decimals can be rational numbers. What about a number like 2 1/3? Is that a rational number? Absolutely. It can fit the form. I can force it to fit the form A over B. 3 times 2 plus 1 is 7/3. Bam. Fits the form A over B. So 2 1/3 is a rational number. It can include negatives. Negative 5. I can make negative 5 fit the form A over B by just putting a 1 over it. So negative 5 is a number. What about a number like 6700ths repeating? If you remember from pre-algebra, you can force this to fit the form A over B because there's a clear pattern. So to turn this into a rational number, all you do is first you say it, 6700ths. So I'm going to put 67 as my numerator, but I'm going to subtract 1 from 100, which is 99. So it's 67 over 99. And in pre-algebra, you learn the formula for that, but right now I'm just showing you how it fits the form, 67 periods. Now, look at a number like this, 0.45721. Can you even say that? Because it never ever ends. You can't even say it. So I cannot make it fit the form A over B. Therefore, it doesn't go in the rational number category. It's going to go in the irrational number category. So if you look at that, any number that you cannot fit the form A over B, irrational. Just throw it in there. So what about pi? You know, you hear about these people memorizing all, 100 places into pi. Great. Good for you. But it never ever ends. So I can't force it to fit the form A over B, so I'm going to put it into an irrational number. A number like this, square root of 25. Can I make that fit the form a over b? Well, yeah, because the square root of 25 is 5, and I can turn it into 5 over 1. So square root of 25 would actually go under this rational number. Now, look at the square root of 26. Can I take the square root of 26? I can't. It's not a perfect square. So if it's not a perfect square, it's going to go into my irrational numbers. Okay? So those are the two categories, rational and irrational. Rational numbers have to fit the form a over b, where b cannot be 0. Now, I haven't given you the abbreviation yet. So, irrational numbers starts with I, we're going to call it I. Real numbers up here starts with R, we call it R. But look, R is already taken up. So what do? The letter we use is Q. Don't ask me why. I don't know. Algebra, universal language, they use it everywhere. So Q is the letter for rational numbers. Hope you're with me so far. It's either irrational or rational. Now, we're going to go down levels. So, we already know what a rational number is. It fits the form, so right away I know I can even go further. What is an integer? An integer is, when you think about kindergarten or first grade, second grade, and you have a number line in your classroom, you had all those negative numbers, 0, and all the positive numbers, that's an integer. They include negative integers, positive integers, and 0. So integers is what you think about the classic number line. Negative numbers, 0, and all the positive numbers. Okay, it's the whole range. So I's taken up. So what am I going to use for integers? Z. Don't ask me why. But Z is the letter that we use for integers. Now, I can even break it down even further. A whole number. What does whole imply? It means there's something positive there. It's a whole number. So a whole number is a counting number, and it includes the number 0. A whole number is a counting number, and it includes the number 0. W is not taken up, so we're going to use W. Okay? Natural number. When math and numbers came into play, 0 was nowhere in when they started trading back and forth for currency, 0 wasn't in there. So when you think of when, math started occurring, 0 was not a number. They would only trade one horse, one goat, or whatever. So a natural number is any number greater than 0, but it is a counting number. And we're going to use the letter N for natural. So if you look at this, the only difference between a whole number and natural number is that number 0. 0 is not natural. So that is the breakdown of the real number system. So now what we're going to do is we're going to look and see, okay, where does it fit in here? All right? So 30. Can I force it to fit the form a over b? I can. 30 over 1. We know we're dealing with the real number system. Every single one of these needs to be R because that's what we're doing in algebra. We know it's real. We know it's rational because it fits the form a over b. It is an integer because it includes that number line negative to 0, so we know it's an integer. We know it's a whole number, and we know it's a natural number. So 30 is all of them, okay? Let's jump over to number 2. Can I make it fit the form a over b? Yeah, I can put it over 1. So I know it's real. I know it is rational because I forced it to fit the form a over b. It's negative, so it includes those negative integers. So I know it's an integer. But it's not whole, and it's definitely not natural. So it stops here, okay? Now, look at number 3. Can I force it to fit the form a over b? 7 times 5 plus 4 is 39 over 7. Yes, I have forced it to fit the form. So we all know it's real. We know it's real. We know it's rational because I forced it to fit the form a over b. But that's it. It's not a counting number, whether negative or positive. So it's not whole, it's not natural, and it's not an integer. It stops right there. Let's take a look at number 4. We're not going to do all of these together. But let's take a look at number 4. Is there a perfect square for 21? There's not. But I do know that it's real. I cannot make it fit the form A over B, so it's not rational. Therefore, it has to be irrational. And it stops. Okay? Now, jump down to number 10. We simplify first. So when we simplify, the square root of 144 is 12 over negative 3, and that reduces to negative 4. I can make it fit the form A over B. There it is. So I know it's real, it's rational, it's an integer, and that's it because it's negative. It stops. It's not whole or natural. Last two we're going to do here. Let's do number 9. 5 and 3/10 repeating. There's that repeating. So if I turn that into a fraction, it would look like this. 3/10. So I subtract 1 to get that 9 place value there. And then I can force it to be 48 over 9. Fits the form A over B. So it's real and it's rational, but it stops. Now, look over here. Anything divided by itself is 1. So just because you look at this and say, oh, you can't take the square root of 17, this is a division property. So when you divide anything by itself, it's 1. So when you simplify, be careful. So it's real, it's rational, it's an integer, it's a whole number, and it's natural. All right, so there is your real number system.